So thanks everyone for joining this. So today I'm going to share with you what we are doing to integrate Apache Spark and DAOS, especially on the Aurora system. So I will start with a brief introduction of the Spark overview, and then I will introduce the two works we have been doing. One is the DAOS Hadoop file system, which enables Spark as enables DAOS as the import and output storage of Spark, and the other one is DAOS Spark Shuffle Manager, which we can utilize this to store the Spark Shuffle data in DAOS. So first, you may know Spark is a very popular big data framework in the industry, and it provides many high-level tools for different use cases. For example, there are Spark SQL for the SQL processing. So this is probably the most well used component people use for a large-scale data processing. And there are also Spark Streaming for the distributed streaming processing, and the MLlib for the machine learning library, and graphics for the distributed graph computation. So Spark, has been there for more than 10 years. So it's had a really good ecosystem built. And it supports more than 50 data source. So it can load data from different data sources and support different file formats. And Spark also has a very good ecosystem, and it supports integration with many popular machine learning and deep learning frameworks like XGBoost and Harvard. So basically, you can run the end-to-end pipeline on top of Spark. So, as big data and HPC and AI has been being converged, so that actually the HPC users have also interested in using Spark. However, Spark, it's designed for a co-located compute and storage architecture. So basically, in a typical Spark deployment, it assumes there are local disks on the node, and we usually deploy HDFS, the distributed Hadoop file system on this cluster, and Spark read import the data from that and also output to this HDFS. And Spark also use the local file system to store some intermediate data generated during the job execution. Especially the shuffle data is the most important intermediate data. So to enable and accelerate Spark on a HPC system, which usually has a disaggregated compute and storage architecture, we first need to support DAOS as the import and output storage. And secondly, we also want to store the shuffle data to DAOS, and to also take advantage of some of the key features from DAOS. So next, I will introduce the two works we have done to integrate the Spark and DAOS. So the first one is the DAOS Hadoop file system. So in the big data ecosystem, the Hadoop file system is basically a kind of standard interface. So Spark has built-in support for the Hadoop interface. It can directly read from the HDFS or the local file system. For many other storage systems like Amazon S3, they actually implement the Hadoop file system interface using their own Java SDK. So then the Spark or Hadoop applications can read from S3. So similarly, we want to develop a DAOS Hadoop file system by using the DAOS API. With this, it will enable the Spark application reading from DAOS. So we use DAOS DFS API because the Hadoop file system interface and the DAOS DFS API, both of them are the kind of the POSIX interface. So with this, now we will enable Hadoop and Spark reading from DAOS, and we have a benchmark using the a benchmark tool called DFS.io, which is a map-reduced job to measure the read and write throughput. So from the result, we can see that with enough parallelism, the client number, we can deliver almost the same read-write throughput as the DFS API. When we have less parallelism, there are a little overhead to start the map-reduce job. Every task is a JVM process, so there are a little overhead there. But that will not be a problem on a real production application. And also because we have enough parallelism. And also this will not be a problem for the Spark, as we usually run multiple threads instead of a process. So here are a few steps that you can use to use the DAOS Hadoop file system in Spark. So firstly, you need to deploy the jar and add this jar file to the class path of the Spark process. So this is what the Java process needs. And once we have that, then we can, if you are using DAOS unified namespace, then we will be able to read data from Spark using the URI. So we can directly add the DAOS prefix to the UNS path, then you will be able to read from DAOS in Spark. And if you are not using unified namespace, then you will need to add the pool and the container UUID in the configuration file, so that Spark know which container to connect and to read the data from that container. So next, I will give an introduction of the Spark Shuffle. Spark is using the map-reduce programming model, and Shuffle is a phrase that to connect the map and the reduce. So imagine you want to group some data and do some aggregation in each group. So in that case, if you have a distributed file, then you will have multiple map tasks read that, and every map task read one partition of the entire data, and then split that data into the different groups. And finally, each reduce task will fetch the corresponding group that belongs to that for processing. So in this case, the map task will output the shuffle data, and in Spark's default shuffle manager, it will store this shuffle data on a local file system. So this is a very I/O intensive and network intensive operation. Usually, it's very critical to Spark performance. So on a HPC system with a remote storage using DAOS, we instead of storing the shuffle data in a local file system, our first attempt is to directly write this shuffle data to DAOS. So we can, the first attempt is to use the DAOS Hadoop file system we developed earlier. So we use this interface to write the shuffle data directly to DAOS. And once the data is in DAOS, the reduce task can directly fetch the data from the DAOS without asking the fetching the data from the remote map task. So this works. However, what we observed is that when we have a large number of reduced tasks, that means we will have a very small shuffle block to read. And in that case, if we have a shuffle block equals to 200 kilobytes, and then it will cause a very frequent file lookup and open. So that will decrease our shuffle read throughput. So with that, then we have our optimized shuffle manager plugin implemented by using the DAOS object API. So instead of storing the shuffle data in a file, we can actually directly take advantage of the DAOS key value model. So we store every shuffle block into a DAOS object using a special key. So we use the reduce ID as a D key and the map ID as A key. So finally, when the reduce task wants to fetch the shuffle data, it can use the correct D key and A key to fetch all the data that belongs to that reduce task. So by using this way, we can avoid opening and multiple shuffle files, and there's no need to seek to a special offset or only read a very small block. So from this result, we can actually, by running a workload, a simple repetition workload, so we can observe that when the shuffle block is 200 kilobytes, by using this object-based shuffle manager, we can have a much better read throughput. So actually, it's 1.5x speed up for the 200 kilobyte shuffle block. And the shuffle write throughput does not change because it already hits the NVMe limit. And here are a few steps that if you want to use this DAOS object-based shuffle in Spark. So first is similarly, you need to add this jar file to the class path of the Spark executor and driver, and then you add a few Spark configuration to let Spark know you want to use this DAOS shuffle manager. And here is a DAOS pool and a container UUID that you want to store this shuffle data. So this is all what we are doing to enable and accelerate Spark with DAOS. And going forward, we have some plans to continue to improve the performance and also the user experience. So for the performance, we plan to switch to DAOS async API in the DAOS Spark Shuffle Manager, because in Spark we usually have multiple threads, and so in that case, the async API will provide a better performance and throughput. And also, our focus is to improve the ease of use. So we want to simplify the user configuration, and it will be much easier to use without configuration too much. And also, we will have much better default values too, so that the user do not need to configure too much. And we will also have some more benchmark and test, so it will cover more use case. So right now, the DAOS Hadoop file system is already available in the DAOS code repo, and the Shuffle Manager will be available in a separate GitHub that will be available soon. Okay, that's all I have for today. Thanks everyone.
Thanks a lot, Carson. I think we have time for a few questions, if any. Any question for Carson?
I have. My name is Anton Brekov, and well, the question is, I saw that you were using the Intel OmniPath. So, which provider you're using while benchmarking? Network provider.
You mean this?
Yeah.
We are using OmniPath, and we are using OFI, in that case, I believe.
I think you are using PSM2 probably, Carson. Right?
Yeah, PSM2. Right,
Yes.
right. Exactly. Mm.